Welcome to my channel Ravikumar Academy. This is a lecture series on single variable calculus. In this class, we are going to learn Lagrange's mean value theorem statement, and we are going to solve some problems based on Lagrange's mean value theorem to verify the theorem. What is Lagrange's mean value theorem? If f is a function such that f is continuous on closed interval ab and f is differentiable on open interval ab, then there exists at least one C in between A and B, that means belonging to the open interval AB, such that f dash C, derivative of f at C, is equal to fb minus fa by b minus a. So this is the statement of Lagrange's mean value theorem. Now we are going to solve some problems based on Lagrange's mean value theorem. So coming to the first problem, this is the function f of x that is given is nothing but a polynomial. When you multiply these three factors, what you will get? You will get a polynomial of degree 3. It is x cube minus 6x square plus 11x minus 6. So when you multiply these three factors, you will get this polynomial. And what is the interval x belongs to? Closed interval 0, comma 4 is given. Now, we need to check whether the first two conditions of Lagrange's mean value theorem are satisfied. If they are satisfied, then we need to check whether C belonging to AB exists or not. Right? We'll try to find such a C. So first of all, what is the derivative? If you find the derivative, you will get the first two conditions. Right? So the concept is every differentiable function is continuous. Every differentiable function is continuous. That means differentiability implies continuity. If a function is differentiable, then it is continuous. So if second condition is satisfied, then first condition is also automatically satisfied. Therefore, we try to find or prove the second condition, differentiability. So for that, we need to find the derivative. What is the derivative of f? It is 3x square minus 12x plus 11. So in this interval, x belonging to 0, comma 4, open interval, in fact in closed interval also, in fact on the entire real line, f dash exists. So f dash is well defined, f dash is well defined in open interval 0, comma 4, in fact in the closed interval also. So this implies f is differentiable in open interval 0, comma 4 is our requirement, right? So differentiability implies continuity. This implies f is continuous. F is continuous in closed interval also, because it is a polynomial, continuous everywhere. Right? Now the first two conditions are satisfied. Right? Therefore, there must exist C in between 0, comma 4, such that this is such a symbol. F dash C is equal to FB minus FA by B minus A. Right? So now, what is f dash x? F dash x is 3x square minus 12x plus 11. Am I right? 3x square minus 12x plus 11. So then that implies what is f dash c? F dash c is 3c square minus 12c plus 11. But what is f dash c according to Lagrange's theorem? Fb minus fa by b minus a. Here a is 0 and b is 4. That is the interval, right? So fb is f of 4 minus fa is f of 0 by b minus a is 4 minus 0. Right? What is fb? What is f of x? F of x is x minus 1 into x minus 2 into x minus 3, right? So you can also take f of x as this, or you can take this. So whichever is convenient, according to the situation, we will take the function. Now what is f of 4? Here finding f of 4 is easy from this version. So I took this 4 minus 1 into 4 minus 2 into 4 minus 3. It is 6. So f of 4 is 6 minus, what is f of 0? F of 0 is 0 minus 1 into 0 minus 2 into 0 minus 3. It is minus 6. So therefore, this is minus 6 by 4 minus 0 is 4. It is 12 by 4, which is 3. So therefore, 3c square minus 12c plus 11 minus 3 equal to 0. This implies 3c square minus 12c plus 8 equal to 0. So using calc, you can find the roots of this. So after solving this using scientific calc, I got 2 minus 2 root 3 by 3, comma 2 plus 2 root 3 by 3. So what are the values of this? 2 minus 2 root 3 by 3 is 0.845, and 2 plus 2 root 3 by 3 is 3.154. 3.154. And according to Lagrange's theorem, we should be able to find the c in between 0 and 4. Right? In between 0 and 4. And here we got two values, 0.845 and 3.154. Both belong to open interval 0, 4. So mission succeeds. Therefore, Lagrange's mean value theorem is verified. It is verified to be true. We'll move on to next problem. Verify Lagrange's mean value theorem for fx equal to log x to the base e. Given function is fx equal to log x to the base e in the interval 1, e. Right. Then let us find the derivative first of all. F dash x. What is f dash x? It is 1 by x. And x belonging to 1, e. The only troubling point for f dash is 0. And that 0 is not there in the given domain. Therefore, in the given domain, this function has f dash has no problem. So therefore, f dash is well defined. F dash is well defined in 1, e. Our requirement is open interval. Here, closed interval also it happens. That means we are showing more than the required. So differentiability implies continuity. F dash well defined means what? F is differentiable. F is differentiable in open interval 1, e. Differentiability implies continuity. Therefore, f is continuous in closed interval 1, e also. Because here also you can take closed interval. Right? Nothing wrong. Then, according to Lagrange, there must exist a c in between AB. Here A, B is A and B are 1, e. So 1, e in the open interval 1, e such that how it should be? It should be like f dash c equal to fb minus fa by b minus a. Right? Now, what is f dash x? F dash x is 1 by x. Then what is f dash c? Then what is f dash c? F dash c is 1 by c. So 1 by c is equal to, here f dash c is fb minus fa by b minus a. Right? F of x is log x to the base e. So what is fb? Fb is log b. Of course, everything is base e only here. Minus log a by b minus a, which is log e to the base e minus log 1 to the base e by e minus 1. What is log e to the base e? 1 minus 0 by e minus 1. This is 1 by c. So this implies you take reciprocal on both sides, you will get c equal to e minus 1. So e is approximately 2.7 minus 1, it is 1.7. So therefore, we are able to find a value of c approximately equal to 1.7 that satisfies our requirement that f dash c equal to fb minus fa by b minus a. And what happens here? This 1.7 lies between 1 and e, open interval. Between 1 and e, 1 and 2.7. Between 1 and 2.7, you have 1.7. Therefore, Lagrange's mean value theorem is verified. It is verified to be true. Now let us solve one more problem, third one. Now let us take this function fx equal to x power 2 by 3. First of all, as we discussed, we should find the derivative of the given function. It is f dash x is 2 by 3 into x power 2 by 3 minus 1. Derivative of x power n is n into x power n minus 1. So therefore it is 2 by 3 x power minus 1 by 3. It is 2 by 3 into x power 1 by 3. But x power 1 by 3 is in the denominator, right? It is in the denominator, and x belongs to the open interval or closed interval minus 8 comma 8. The only troubling point for this function f dash is 0, because it is not defined at x equal to 0, and that 0 is present in the given domain. So at some point of the domain, the given function, the derivative of f is not defined. That means derivative does not exist. Therefore, f is not differentiable at x equal to 0 belonging to minus 8 comma 8 interval, belonging to the given interval. So therefore Lagrange's mean value theorem cannot be applied for this particular function in the interval minus 8 comma 8, right? So that is how we can solve the problems based on Lagrange's mean value theorem. In the next lecture, we are going to solve some interesting applications. Please subscribe to my channel if you have not subscribed yet. Also like the video, share it with your friends, and if you want to learn any new concept, please mention in the comment section. Thank you.